A classic stationary gas engine is a fixed internal combustion machine designed to power equipment such as pumps, generators, grinders, or factory machinery. By converting thermal energy from fuel combustion into mechanical work, it served as a reliable power source in both rural and industrial settings. These engines were manufactured in various forms, ranging from simple two-stroke to more advanced four-stroke designs, with different horsepower ratings and cylinder configurations to suit diverse applications. Restoring such an engine typically involves careful inspection, disassembly, cleaning, and either repairing or replacing worn components before reassembling and testing to ensure proper operation. Beyond their practical use, stationary gas engines hold strong cultural significance today. They are frequently displayed at enthusiast gatherings and museums, highlighting the technological evolution of internal combustion and preserving an important part of industrial heritage. The Urggon Cosmos gasoline engine, believed to have been manufactured between 1905 and 1910, represents a rare and fascinating piece of early stationary engine history. Designed as a fixed power source, it was intended to drive machinery via belts or couplings, rather than being mounted on vehicles. A notable restored example features a large 106 centimeters flywheel and is mounted on a rolling frame, making it both functional and display-worthy. The restoration process included replacing key components such as bearings, crankshaft, and timing gears, ensuring reliable and smooth operation. This model is also equipped with a safety mechanism to prevent dangerous backfiring during startup. Known for its quiet running and solid engineering, the Urggon Cosmos engine is now extremely rare, with fewer than 5 surviving units believed to exist, making it highly valuable to collectors and enthusiasts. The Gardner stationary engine represents one of the finest examples of British engineering, manufactured by L. Gardner and Sons Limited, a company renowned for its exceptional engines from the late 19th century until the mid-1990s. Unlike mobile units, a stationary engine was designed to remain fixed in one place, providing reliable mechanical power to a wide variety of machinery. Gardner engines earned a reputation for strength, reliability, and precision, which made them highly valued across different industries. These engines were widely used to drive swing bridges, farm machinery, fairground rides, and industrial equipment, ensuring smooth and consistent operation even under demanding conditions. Their applications extended to powering generators, water pumps, and workshop machines, highlighting their versatility and engineering adaptability. What set Gardner engines apart was not only their robust construction, but also their longevity, with many examples still in service today. This durability reinforced their standing as benchmarks in the engine manufacturing industry. Today, Gardner stationary engines hold a vintage status and are treasured by enthusiasts, collectors, and museums. Preserved examples, such as those displayed at the Amberley Museum, continue to demonstrate their remarkable performance and historical significance, reflecting the enduring legacy of Gardner's engineering excellence. Baldwin Beexstein gas engine is a historical stationary internal combustion engine, likely dating back to the late 19th or early 20th century. It features a large flywheel and visible mechanical components, typical of early engine design. Powered by gas from an external tank, it uses a reciprocating piston to convert combustion pressure into rotary motion via a crankshaft. This rotation could then be transferred to external machinery through belts and pulleys. Engines of this type played a vital role during the Industrial Revolution, offering a simpler and more efficient alternative to steam power, particularly in agriculture and small-scale industry. The Deutz E12 is a vintage tractor produced in 1907 by the German manufacturer Deutz. It is equipped with a single-cylinder, 4-stroke petrol engine that delivers 4 horsepower at 350 revolutions per minute. Despite its relatively small power, the machine was reliable and well-suited for light agricultural and industrial tasks during its time. With the weight ranging from 780 to 800 kilograms, the Deutz E12 had a sturdy construction, reflecting the engineering quality of early 20th century machinery. Today, it stands as a remarkable example of Deutz's pioneering role in engine and tractor development. The Stickney hit-and-miss gas engine, built by the C.A. Stickney Company of St. Paul, Minnesota, is a stationary internal combustion engine using a governor-controlled system. Its rugged design, fuel flexibility, and efficiency made it popular in early 20th century agriculture and industry for powering mills and machinery. The old Robinson patent hot air engine, patented in 1886 by Horace Robinson of Manchester, is an early form of closed-cycle Stirling engine designed for driving small machinery. Built by Robinson and later licensed to L. Gardner and Sons Limited, it offered a quieter and safer alternative to steam engines. The Robinson engine works on the Stirling cycle, using air as the working fluid. Its key feature is the combination of a displacer piston and a power piston. The displacer moves air between the hot and cold ends of the cylinder, while the resulting pressure difference drives the power piston, connected to a crankshaft and flywheel to generate mechanical work, typically coal-fired or fueled with solid tablets. The engine had modest efficiency, around 7 to 10%. Despite this, it gained recognition for its reliability and low noise, often used to power light machinery or organ bellows. The 16-horsepower Austro Oil engine, produced by Ronaldson Bros and Tippett in Ballarat, Victoria, Australia in April 1915, represents a significant milestone in early Australian engineering. Bearing engine No. 1398, this powerful machine was part of a series of Austro Oil engines, which were designed to operate on kerosene or similar fuels. Unlike modern engines, it relied on a simple yet effective tank-cooled system, where water stored in a tank was used to regulate engine temperature. With its 16-horsepower rating, it delivered considerable power for the time, making it suitable for demanding farm and industrial applications. These engines were typically used as stationary or portable units, driving equipment such as pumps, threshers, and saws, thereby revolutionizing rural productivity. The rugged design and heavy-duty construction ensured that the engine could withstand continuous operation in tough conditions. Known for their reliability and endurance, Ronaldson Tippett engines became a trusted companion for Australian farmers. The 16 HP Austro Oil engine not only reflects the ingenuity of early 20th century engineering, but also highlights Australia's industrial heritage, where locally manufactured machinery played a key role in supporting agricultural and economic growth. Big some height as is. The Rustin Hornsby AP8 horsepower is a vintage stationary internal combustion engine built by the British firm Rustin and Hornsby. With an open crank design and 8 horsepower, it was commonly used in agriculture and general industry. Many feature a low-tension ignition system and were mounted on trolleys for mobility. Today, the AP8 horsepower represents an important piece of industrial heritage, showcasing early 20th century engineering and oil engine technology. The Engine and Machinery Museum, known as Stickney, is located adjacent to the Arbitrage Museum in Northampton and was notably featured during Coulter-Natten 2009. This unique museum celebrates the history of engines, industrial machinery, and mechanical craftsmanship, offering visitors a hands-on glimpse into the world of historical technology. At the event, a captivating performance began with a woman dancing rhythmically to the deep, resonant thump of a raw oil engine coming to life. The excitement quickly escalated when a 12-cylinder Rolls-Royce Merlin engine roared into action, filling the space with its thunderous power. The museum's collection includes numerous fascinating exhibits, such as hot-bulb engines, the iconic BP man from Rimforsa, and traditional blacksmithing demonstrations. Visitors can also explore working tools like wood splitters and admire a vintage bus, all showcasing the practical applications of engines and machinery in everyday life. Skilled workshop employees from Hilton's demonstrated historic techniques, providing insight into industrial practices of the past. For the first time ever, the museum presented a live steam engine outside its premises, situated along the Motala Strand, offering an extraordinary spectacle for enthusiasts and the general public alike. With its combination of interactive demonstrations, rare machinery, and lively performances, Stickney offers a vivid journey through the evolution of engines and mechanical technology, celebrating both innovation and nostalgia for generations of visitors. Hey! Perkins P3 marine engine is a classic three-cylinder diesel engine produced by the renowned British manufacturer Perkins. Among its notable models, the P3.144 from the mid-1960s stands out as a prominent example of vintage marine engineering. Designed for a range of vessels, including pleasure craft, workboats, and small commercial boats, the P3 series offered dependable power and efficiency suitable for various maritime applications. As with many Perkins engines, the P3 demonstrated a strong reputation for reliability, robust performance, and fuel economy, earning the trust of boat owners worldwide. While these engines are considered vintage, enthusiasts and restorers often seek specific parts and technical manuals through secondary sources, such as specialized dealers or hobbyist forums. Despite its age, the Perkins P3 remains a testament to durable marine engineering, reflecting Perkins' long-standing commitment to producing practical and enduring diesel engines that continue to be admired by collectors and boating enthusiasts alike. The station arm motor on the conch represents a type of stationary engine, a power unit designed to remain fixed in one location while supplying mechanical energy to other equipment. Unlike vehicle engines, which provide mobility, stationary engines are mounted permanently and typically drive machinery, such as generators, pumps, or industrial devices. These engines convert thermal energy into mechanical work, often through the reciprocating motion of pistons powered by internal combustion or steam. Their key characteristics include a fixed installation, a primary purpose of delivering power to mobile systems, and a reliable method of energy conversion. Stationary engines like the Urggon model were historically vital in rural and industrial settings, where they replaced manual labor and animal power, making them an essential foundation for mechanization and early industrial development. Today, they are preserved as historical machines,